All right. So first thing I want to do, there's a worksheet that says parabolas on it, but I'll do that in a second. I want to. So the first thing I want to do is give you a definition of a parabola. Oh, my bad, dude. I left somebody out there the whole period once. It's awful. Bell rang and they poked their head in the. Anyway, sorry, man. All right. So the first thing I want to do is talk about what the definition of a parabola is. And we really haven't talked about that at all other than the slice through a cone. So this is an algebra definition, not a geometric definition like that slice. Okay? So a parabola is this. Parabola. All points in a plane that are equidistant from a fixed point. And by the way, that fixed point is the focus, which we have talked about, and a fixed line. And the line is what we're introducing today officially, and that is the directrix. So I'm just going to give you a random example. This directrix could be anywhere. The point could be anywhere. Now, the only parabolas we talk about in this class are directrices that go horizontally or vertically. But you could have a tilted one. We just don't cover it in Algebra 2. And very little in pre-calc. So hypothetically, let's just say my focus was right here. All right, up there at 1, 4. All right, and let's just say my directrix is right here. Now, a directrix is the fixed line, right? So a line has an equation to it. Don't just say, oh, the directrix is down there at 1, -2. It's a line. So in this case, because the line goes through the y-axis at -2, we would say that that is y = -2 is my directrix. But to show you the definition, it's neither here nor there. So hypothetically, I draw a line called a directrix, it's fixed. I draw a point, it's fixed. Neither the focus nor the directrix is a part of your parabola. But it just like the center and the radius is not a part of your circle. But it helps you get the points that are on there. So let me just mark the easiest points to use your definition for. So what is the easiest point that clearly is the same distance from the focus as it is from the directrix? I think it's that one right dead in the middle. Turns out, guess what that's called? Your vertex. All right, so that does end up being the vertex. I'll mark it, but that is one point. Now, the next point, I think, couple points that are the easiest ones to find, or to kind of think like a square. If that distance is 6, if I went over 2, 4, 6, that point is the same distance right here. You can see it, 6, 6, right? So that point and that point is the same. And then if I did that over here, 1, 2, 3, 4, 5, 6, that point is the same distance there as it is there. And normally, those are the 3 points that I mark, because it just so happens that this distance from here to here is C, and that distance is my lattice rectus. But there are all other kinds of other points that are harder to verify. But like, for instance, can you kind of see that maybe right here, right here, that distance and that distance are about the same? And maybe right here, that distance and that distance are about the same? And maybe right here, that distance and that distance are about the same? Or even there, that distance is the same as that distance? So if I measure it off, I could do this all day, right? Just find points. It'd be harder to check. I could get a ruler out maybe and get a close guesstimation. But there are all kinds of points that if you measured them would be the same distance from the point as they are from the line. And if I marked enough of them, I would get a nice and connected them all together, a nice parabola. Except I'm not that concerned that your parabola is so awesome. I'm just like, give me an idea. If I want it awesome, you can pull out your calculator, right? If I want it just decent, just give me 3 points. And that's why we use the vertex. We go up C to the focus. We mark off our lattice rectum. And those 3 points are good enough for most of the work that we do. If you can use the lattice rectum. And then I showed you the cheap trick, in which case you can't. Because if the graph is really skinny, I mean, your focus is so close to the vertex and your directrix is so close, it's kind of hard to, they're not very helpful, if helpful at all. They might even be hurting. But that's what the directrix is. So if I ever give you information, you've got to be able to figure out what that directrix is, but don't make this very common mistake. All the time, I see people, like, let's just say I gave you the focus, and you come in here and you go, all right, here's the focus. And then I give you a vertex, and I go, all right, there's a vertex. You get that. And you go, oh, well, if you are 4 away from the focus, then I must be 1, 2, 3, 4 away from the directrix. And then I ask, well, what is the directrix? And they tell me -3, 3. Except the directrix is not a point, is it? So it can't be that, but what would it be? X equals -3. It's the line going through that. And that line might be vertical if the graph is opening up left or right, and it might be horizontal if it's going up or down. Now, you don't need it to graph. You'll probably never use it again after this chapter, unless you go to a math tournament and they say, what's the equation of the directrix or something like that. But that's what it is. And on your test, you'll have to answer that. What is your equation of your directrix? And the bottom line is you figure out what C is, and C is the same going that way as it is going that way. Because literally, that's your definition of a parabola, right? All the points on the curve that are the same distance from a fixed point as they are from a line. So those two distances have to be the same. Are you with me? Now, real quickly, which direction will the graph go if I told you that this was the focus? If I told you that was the focus and that was the directrix, which way are you going? Does everybody see that the vertex is in the middle and I would be going that way? All right. What if I told you that's the directrix and that's the vertex? Where would the focus be? Below. And if that's the focus, which way am I going? Down. Okay. What if I told you this is the focus and that's the vertex? Which way am I going? To the right, because the vertex is in the middle. So we have to be going that way. Have you noticed on all of these, what is leading the way of the 3? Your focus. And what do you, don't you lead the way with your eyes? I don't see a whole lot of people walking around the hallway doing that, right? You get in a little bit of trouble. So most people lead with their eyes, which is why I came up with this lame picture. Now, it might help you, it might not. At the very minimum, maybe it brings a chuckle. So I used to teach regular algebra 2 and regular pre-cal a long time ago, and they really struggled with what we just talked about there. I don't know which way it's going. So I said, okay, you get desperate when you teach some of the regular classes. So I thought, okay, well, what if we kind of made a little diagram? I said, if this was your directrix, and this is just an example of one going up. If that was your directrix, and this was your vertex, and this was your focus. So I said, well, you always lead with your eyes. You walk around eyes first, right? Focus with your eyes. So I said, well, let's make a dude, right? Focusing, right? And I said the heart, right? Kind of in the shape of a V, right? So if you think about this, so there's his heart right there, right? He's, I don't know. I used to make him like Superman, but I guess you could just make him a really happy dude doing the splits, cape, whatever. I don't know, whatever. But the point is, if you can visualize, I told you it was lame, but it might be helpful. Focus with your eyes. Vertex is your heart. Focus, vertex, directrix, whatever works for you. But if that helps, that works either way, right? Legs, vertex, focus with your eyes, flying that way. Again, I told you it's one. Might work for you. They were like, yes. They were so excited. I don't know that most of you need that, but again, sometimes dorky stuff. I mean, singing a song about the Pythagorean theorem is pretty dorky too, but how many people know it? Yeah, right? And in your head, you're like, I mean, anyway, what did I say? Oh, Pythagorean theorem, sorry. Oh, the quadratic formula. The opposite of B, plus or minus, whatever. All right, so here's what we're starting with today. We started with that. And by the way, I've got pretty decent notes on parabolas. I got a special sheet. We only learned that. Now we're adding that. So if you know that a parabola is opening to the right or the left, you no longer can use the y minus k equation. You have to use the x minus h equation, and then the y stuff will be squared. Are you with me? So just have that burned in your brain. And like right here, do you see how I'm completing the square on this problem? By the way, I don't even like the way I did it right here. I'm going to do it a little differently for you. It's not wrong, but I'm going to do it a little differently. I usually do this, and I'll show you this in one of the problems we do today. But if I'm looking at a problem like this and I have to complete the square, I immediately identify what is being squared, the x stuff. So I now, this is old, immediately move that to the right. So what I would have done had I done this today and not a couple of years ago, whatever, I would leave the negative 16y plus 80 on the left, subtract everything else over, minus 16x, and then I would start completing the square like that, rather than complete the square where it is and at the last second flip-flop it. Again, I wouldn't do this anymore. And people that go, oh yeah, but you avoid the negative. So what? It truly, the negative is not a big deal. And half the time when you move it over, it ends up being positive anyway. So I'll show you that in a second. But again, if I looked up here and the y's were squared, just take all the y's, y squareds and the y's, move those over to the right. All right, and you'll be fine. Because the only thing that's changing between today and yesterday, I think you'll see, is what we've just talked about. Oh, one last thing. This is not going to mean much to you, but I'll talk more about it when we start ellipses on Monday. But there is something called eccentricity. You can see I put, or eccentricity, depending on how you pronounce it. But you can see here, the E is always 1. On a circle, the E is always 0. On ellipses and hyperbolas, it depends on the ellipse and hyperbola. But one of the most common questions, you'll go to a math tournament and they'll go, what is the eccentricity of the following parabola? And it's 1. It doesn't matter what the parabola is. And it's so funny to me, and it's not that funny, but like it's kind of funny to me. I'm sitting up there looking, and I look around, and everybody's like, sometimes it's our student busily working away, trying to solve, and I'm like, what are you even doing? Like, I don't even know, because it's always 1. And the reason why it's always 1 is because even a skinny parabola, even a really skinny looking one, what happens if you zoom in on it? You zoom in on the vertex, it looks wide. It's a matter of perspective. So literally every parabola, like if I were to throw a baseball, like with a 10-degree angle, it looks like a really wide parabola, doesn't it? But what if I throw it off the top of a giant building? What does it end up looking like? A really steep parabola, doesn't it? So every parabola, simply by zooming in or zooming out, like I could take a really wide one, zoom way out, and it looks really skinny. I could snap an image and put it on a skinny one to the exact same shape, with the exception of up, down, left, or right. A circle. I can have big circles or small circles, right? I can zoom in on that. No matter what, I'm still going to get a circle. It still has that same shape, right? I can't zoom in and it turns into an ellipse, right? So that's why ellipses, in a way, that's why circles and parabolas don't have changing eccentricities. But I can't take a really skinny oval and zoom in or out and make it a very rounded oval, can I? I would have to do stretches and junk like that. I would have to change its form. So if you're ever wondering why eccentricity or eccentricity changes with hyperbolas and ellipses, is because they do have different shapes. But technically speaking, circles and parabolas do not. It's just a matter of perspective. So please memorize that eccentricity is 1. And on circles, it's always 0, which should be easy to remember because circles are in the shape of 0. So all of that said, let's just talk about some of these. We got a classwork worksheet. We're just going to plug as far as we can through on this. If we can't get to the end, you don't have to finish it up because it's classwork, but you can if you just want a little practice. So let's start right here. Number one, can you look at this and tell me which way it's going? Take a guess.
Left.
Why left?
I know it's left to right. Negative.
Okay, so because it started with an X, unlike what we did before with starting with a Y, these are left and right opening parabolas. And if positive A meant up, chances are positive A means right, and he was right. So negative A must open leftward. So right now, I know this opens leftward. So when I'm marking my directrix and my vertex and my focus, I know the focus is to the left of the vertex. So initially, they ask you for vertex. So vertex is what here? Take a shot. So 3, -1. And notice that if you're in that habit of always pulling the X coordinate from the squared part, get out of that habit. You pull the X coordinate from the X part, Y coordinate from the Y part. So 3, -1. Take a shot at what the length of the latus rectum is. Still 8. So nothing changed there. Take a shot at what the A value is. Still -1/8. Take a shot at what the absolute value of C is. 1/4 the latus rectum, 2. So none of that changes. And again, if you're wondering, if I didn't mention this, if you're wondering why I put absolute value in there, technically, when A is negative, C is negative. Just technically. But since we don't think that way, we don't use the little formulas the book uses. We use C to just find the distance to the focus in the directrix, and distance is positive. So I just put absolute value so you don't have to quibble about that. Now, based on this, I can come down here and sketch the vertex. There I did. Vertex, 3, -1. Where would the focus be? Left, right, up, down? Left, because the graph is going left. Now, it's easy to go left. How much? 2. And mark that point. And you can see that that point would be right there. That's the focus. That's 1, -1. So the focus over there at F. But here's what I want you to be able to do, and you'll have to be able to do it on number 2 here. I want you to be able to think this way. If this is the vertex at 3, -1, and I'm moving left 2, am I going to be changing the Y coordinate? Notice it stayed -1. What will I be doing to the X coordinate if I'm heading left? Subtracting 2. So I can go 3 - 2, mark the 1 down. You're going to need that when your C value becomes really tiny like it does in 2. You got to be able to think that way. If I ever want something to the right, subtract it. I'm sorry, to the left, subtract, down, subtract, right or up, add. But if it's left I'm subtracting from, change the X coordinate. If it's Y I'm subtracting from, change the Y coordinate. And then what's your axis of symmetry? What trick did I teach you last time?
You just take whatever's squared.
Take whatever's squared,
Equal to 0.
set it equal to 0 and solve. Don't write -1, write Y equals -1 because that axis of symmetry, remember, right? It is running right through there. Even though I didn't ask you to sketch that, but it is. Okay? Now, the directrix. What did we learn about the directrix? Is it to the left or the right? Yeah, because I lead with focus, vertex in the middle. Directrix is like the legs. So I'm going to say, well, if its focus is 2 away from the vertex, what does the directrix have to be? So I go 2 to the right. But don't say it's 5 -1 because the directrix is a line. So what do we say? X equals 5. So you have done everything now but graph it, but you didn't even need to mark the directrix to graph it. I put it in there, even though I don't remember if it said or not. So how do I graph this? What would be the easiest way to graph this? We did this last time. Use the latus rectum at the focus. The latus rectum was 8. So I'm going to, from here, I'm going to go up 4, down 4, and from the vertex, go through those 2 points. And that's good enough. You with me? All right, this one's a little uglier in terms of finding the information, a little easier in terms of graphing. So starting out, what's the vertex? -2, -1. If you chose to plot that, it would be right there, and that is my vertex. What is the length of my lattice rectum? 1/4. Not very helpful. What is the A? 4. What is this absolute value? C? 1/4 of a fourth. Really unhelpful. Now, your directrix and your focus are not going to be pretty here. And in a regular Algebra 2 class, they would never ask you the directrix and the focus just because they weren't pretty. They typically don't ask directrix and focus unless you get a really pretty C value. But you, what the heck? Try something else. What page are we on? So this one's going to be a little nastier. All right, so we said vertex, -2, -1, and you can mark that if you want. We said length of the lattice rectum is a 4. A is still 4, but C is 1/16. Very weak information if I want to use that to graph, which is why we came up with the cheap trick, right? And then directrix and focus means those are going to be weird values. So before I get to those, what would the axis of symmetry be? Lord have mercy. You're learning. Right here, what's the axis of symmetry? Y equal -1. And I'm going to try to graph it. So, but I'm going to go back and talk about directrix and focus. But how do I graph this? And what does the trick normally tell me to do when you have an A that's 4? You would go up 4 over 1 each way. But this time, which way is the graph going? It's going to the right. So you're going to go right 4, up and down 1. So 1, 2, 3, 4, up 1. 1, 2, 3, 4, down 1. And that's going to be good enough for us to sketch this. Now, if you're asked to find the directrix of the focus, you still got to do it. So I want you to think with me. Where do you know the? I'm going to do focus first. Where is the focus with respect to the vertex? Right, left, up, or down? Say it again. Right. So if I move to the right, is my Y value changing? No, so it's still -1. How much to the right am I going to move? C, 1/16. So from -2, am I going to add or subtract 16 if I move to the right? I'm going to add. So what is -2 plus 1/16? Well, you could find a common denominator, or you could write it as an improper fraction. A proper fraction. I like improper fractions. -31/16. So I'm going to say, all right, the focus is at -31/16, if anybody wants to know. But very clearly, trying to mark that to the right is really tough to see. Now, where would the directrix be? To the left of that. So I would do what to that -2? Subtract 1/16. Well, that finding the common denominator there now gives me -33/16. But it's not a point. What is it? It's x equals, because it's that vertical line there. So x equals -33/16. Now, you need to be able to think this way because you have to do it more and more when you start getting into things like foci and vertices with ellipses and hyperbolas. You got to start thinking, wait a minute, what am I changing? I'm changing an x coordinate or a y coordinate. So let's change the x coordinate or use it appropriately. But again, to graph, boom, we're done. All right, let's try a couple of these other things. Anybody got a question? Or are we good? All right, what about 3? So 3 says, I'm giving you some information here. Graph the parabola, find the equation, graph the parabola. So you know x equals -2. Can I please caution you? Please don't miss, like if you write this, y equals, if you sketch this in right here for x equals -2, everything is going to be a disaster on yours. The x's and the y's are going to be switched. Your focus is going to be wrong. Everything's going to be wrong. I mean, it's going to look kind of have some similarities, but it's going to be a mess. Please don't do that right there. Okay. So right now it's back. Awesome. So right here, I'm going to go x is -2. And the focus is 4, -3. So there's my directrix. There's my focus. Where would the vertex be? Out to the right, in the middle, or in the back? In the middle. And since I'm counting and I see 6 here, that means 3 from either one of those is your vertex. Now, which way is this parabola going? So are you going to try to plug this information into this, or your information into this one? Second one. So don't use this, since you know it's going to the right. What can you immediately plug in there? And what is my vertex, by the way? So if your vertex is 1 down 3, I come up here and go x minus the 1, a, y plus the 3. Now I need a. How can I find a?
Find the C value.
The C value is 3. And if the C is 3, what's my lattice rectum? 12. And if my lattice rectum is 12, I can graph this. But what can I get from the lattice rectum? At least the absolute value of A is 112. But would it be plus or minus? You would have to go in and decide that. Have to be plus if it's heading to the right. So you use positive 12 in there. And plug your 112 in, and you're good to go. You with me? Okay. What about, oh, and I didn't graph it. What would you do to graph it? From the focus, what would you do? Up 6, down 6, and sketch it, right? All right, what about number 4? What is the equation of a parabola with the vertex of 2, 3? So I'm going 2, 3 for the vertex, and 2, -1 for your focus. So which way is this graph going? Down, because you lead with your eyes, right? So that would mean if I wanted to do this, I am what, 1, 2, 3. My C value looks like it's 4. Now it didn't ask me for the directrix, so I don't have to sketch it. So right there, if C is 4, what's your lattice rectum? 16. And what would your A be because of that? -1/16. Good, because you know this graph is going down. So what I could do is from that right there, I could go 1, 2, 3, 4, 5, 6, 7, 8. And then to the left, 1, 2, 3, 4, 5, 6, 7, 8. And I can sketch the graph through that. I'll give you better graphs to go with your work on a test. But how would I find the equation? Now what am I using? Y or X starting out? Y. So I got Y. I have that equation using the vertex, which is 2, 3. I have Y minus 3 and X minus 2. And how do I find A? And by the way, every year I have somebody that plugs in the focus in there to find A. Why doesn't that work? It's not on your curve. It's got to be something on your curve. So since I don't have a point on my curve that I'm 100% confident about, now you could argue that 6, -1 or 10, -1 is on there. So you could do that to find the A, but we already know A, right? So I come in here and I mark my A and put in my -1/16. And these are tricky problems on your test. So if you're like child's play, well, awesome. You know parabolas pretty well. All right, what about, and here's what I want to talk about, completing the square. Okay, like I'm going to use this. So completing the square, this is where it's different from the work that you see on your notes. So I kind of ascribe that this is a better way for my students to do well on this. So rather than just leaving the x squareds here and moving everything over, I habitually now grab anything that's squared, including the terms that match it, and I subtract them to the other side. And I honestly could not care less whether the signs end up being negative or positive. It truly is not a big deal. So this is what I do in step one, and then I don't have to switch them in the end. Now, how do you complete the square of that stuff on the right? What would be your first step? You have to do what? What do you always do when you complete a square? Pull out the a value. Now, it turns out your a value is not -1. It's going to end up being -1/16 or something like that or whatever. But you're still going to pull out whatever you think is that a value, right? And it looks like a -1. So I'm going to factor out that -1, and that leaves me with x squared plus 2x. Now, completing the square, what would you do? Half the 2 is 1, square the 1 is 1, but what did I really add? -1, so subtract 1 from the left, and that gives you this. Now, somebody tell me why I can't just leave that -1 out front, factor this, and call it a day. Why can't I? Because 16 makes this bad form. Your form is y minus k, not like ay minus k or some other number. It has to have a 1 in front of it for your parabola to make sense, right? So that means I got to get rid of a 16. Now, I see all kinds of ways people butcher this. So let me give you 2 ways you can do it. Now, if I divide by a 16, dividing by a 16 into something plus something or something minus something is kind of like the distributive property. It has to go under both parts. But dividing this by a 16, technically, there's 2 things that are being multiplied together. And if they're being multiplied together, you can just put it with one of them. Do you see the difference? Here it's 2 things that are added. Here it's this and this are multiplied. So one way you can do it is to divide by 16, y minus 2, and then divide by 16, just put it under whatever is out front and call it a day. So the other way, if you're looking at this and you're like, that bothers me. The other way is just to do this and say, I'm going to multiply the left side by 1/16, and I'm going to multiply the right side by 1/16. And if you do that, you distribute that, y minus 2. And right here, what's -1 times 1/16? -1/16. So you don't even really get a chance to multiply it in yet because you're happy with the form right now. So it's your call. I don't care. But that would be completing the square here. And I'm going to do the same thing again right here. So same thing. If you we're over here on number 6, I'm going to take everything squared, which is that stuff. I'm moving it to the right. So I'm going to leave the -x and the 46, and I'm moving the 3y squared minus, it becomes -3y squared and positive 24y to the other side. So what's the first thing you do after this? Pull out that -3. That leaves you y squared minus 8y. A lot of y'all missed this on your test. You pulled out like the 1/8 or the 3 or whatever and forgot to change that b value. Just be careful about that. Sometimes I knew it was careless because I saw you do it right somewhere else. So it's an easy thing to forget. And then how do I complete the square here? Half of the 8's 4, square it's 16. But what did I really do? So I subtract 48 there. So I get -x minus 2 equals -3y minus 4 squared. Can I stop there? No, because that negative. So if I divided this by -1 and that by -1, this gives me x plus 2 positive 3 y minus 4 squared. Not too bad. Last thing. Oh, we're actually in a good place. Right here. Find the equation that's the closest representation. And then if you try to find, remember, if you try to find A by guessing with the lattice rectum, it's a good chance you're going to be wrong unless you're lucky. But before we even do that, because we might run out of time by the time we get to the end, what is the answer to all of the problems in number 10? 1. If we can get that right, well, I would say in a normal year, it happens every year. It shows up one time at a math tournament. You guys, I don't know, who knows how many we'll go through. One that ciphers is probably going to be it. And good night. Briarwood's, theirs is so simple. I don't even know if they know about trick questions. Anyway, that might have been harsh. Sorry. Good night. Where am I? Go back to where we were. All right, here we go. So, how do I come up with that equation? What's a great place to start? Even before the vertex. What kind of parabola are you using? Up or down or left or right? A y? I start with a y? Okay, so I'm going to start with y. There's going to be an a, x something squared. Now, yes, the vertex is 2, -1. So 2, x minus 2, y minus a -1, y plus 1. Now, how am I going to find the a value? 2 ways actually look really well. You can plug in a point. Do you see a point that you're convinced of its value? 3, -4. So try that. If you plug the 3 in and a -4 in, you get -4 plus 1 equals a 3 minus 2 squared. And I get 1 squared, which is 1. So a is -3. Can I show you something though? Did you see it? Right here. Down 3 over 1 each way. If you ever see that on the skinny ones, what the point is when you go up or down or left or right a certain amount and then up and down 1, that's your a value. So if you happen to notice, now granted, how much time did I save? What, 13 seconds? I mean, not much. But if I happen to go, wait, down something over 1. So it must be down 3. There's my a. But I found it pretty quickly that way. Now, it's really hard to look at this one and go, all right, what did I do to go over 1 over 1? I don't know what that is. 1/8, 1/10, 1/7. I have no idea. So it's not helpful most of the time. Even here, right here. How much did I do to go up 1, down 1? I don't know. That's why I'm not going to use that most of the time. Most of the time, like he said, it'd be much easier just to find a good point. All right, what about, I got 3 minutes. What about number 9? What do you want to start with? X equation, right? So x something, a, y something squared. And sure enough, my vertex is 3, 2. So x minus 3 out front, y minus 2, but I still need to know the a. Now, the cheap trick didn't help me. Most people, the lattice rectum, you're not going to be able to eyeball that and see it. So what would you do? Find a point. You see a point, you're pretty to me, it doesn't cross at 0, 6 or 0, -2 to me. If you look close, you can see that. So what does it look like it crosses at? Even here, I would probably give you credit if you used -1, 7, but it doesn't even look like it really crosses there. But it does look like at -3, 8, it's right on it, or at -3, -4. So look and find the one that's the best. I think there might be one in your work where there's like 3 that look really good. In that case, I would take the 3 different a values if they were different. So right here, let's just say I use -3, 8. So if I used -3 goes in for the x, 8 goes in for the y, put an a in there and solve, and I end up getting -6. That ends up 36. So if a is that, then a is -1/6. You know with me? And there's really no difference on a. I'm just gonna let it go, but except you start with y. All right. Enjoy the weekend.